All right, so I got some curve here, and we want to estimate the area under the curve using a left Riemann sum, maybe from 0 to 2. All right, so we really close here, computer generated, but left means go up the left side, right? Rectangles, right? We got that. We've been doing this for a long time. All right, the right Riemann sum, okay, same thing. Here's my curve. I'm going to do a rectangle. All right, on these, they're all a half as far as my delta x, but I'm going up on the right side to draw my rectangles. All right, now on these two, these are the two we've done so far. This one right here, after you can draw them, you successfully can draw them, you've got to analyze the picture. This one, is this an over or an under estimate? It's an under, and this one is a, which is kind of common sense, right? Above the curve, extra stuff, below the curve, not enough. Now, I have referenced, but we've never done anything, midpoint Riemann sum. If I know that delta x is whatever it is, in this case 0.5, I know how wide it is, then I can find the middle, right? I can find the midpoint. So in between each one of these rectangles, finding the middle and then going up. And then so you would literally have to find, what's halfway in between 1 and 1.5, 1 1/4, right? So then the number you would plug in would be 1 1/4. Halfway in between your midpoint, and then so your rectangles look like this. All right, now out of these three, which one's going to give you the best approximation? Midpoint. Okay, and that's what we're going to do. I mean, we've introduced this Riemann sum here at the beginning. We're going to go to trapezoid rule. We're going to go to some other rules, and every time we make a change and we introduce a new one, then it's going to give us a better approximation every time. Okay, all right, so just kind of a visual, I wanted to introduce that, okay, in a visual type of way. All right, now let's see if we can't take some type of function and then just write, not actually do the math, but write the Riemann sum out. Okay, so let's make clear indication that we know the difference between just an integral and a Riemann sum. Okay, so Riemann sums, I'm going to abbreviate here, left, right, midpoint. Okay, because I'm going to address all three of them. All right, I clearly, definitely want you to know a Riemann sum gives an approximation. As compared to an integral. An integral gives the actual area. So depending on what the question asks for will determine which one you want to go with. Sometimes it'll very specifically say, it'll say use a Riemann sum to estimate the area under the curve. It might say give a Riemann, or use a Riemann sum to evaluate the integral. Okay, if you're using a Riemann sum to evaluate an integral, you are still getting an approximation. Okay, if they want the actual area, it'll be more precise, and it will indicate you're supposed to find the actual area by taking that integral. Okay, now let's take a look at a question where we set up all three, so just so that you see the difference. Okay, so as a question, let's say it says calculate all three Riemann sums for, and we'll make it a relatively easy curve because I just want the setup more than anything else. So our f of x is going to be an x to the third, all right, over the interval from 0 to 2. And then we'll say using 4 equal subintervals. And then so that you'll get used to what you're going to see on the IU exam. All right, sometimes you'll see a question like this, and then it's going to give you very specific questions. Do not simplify, do not evaluate. All right, and so they're wanting to shorten the question and just see if you can do the setup. So on this one, let's practice the do not evaluate. Okay, so first thing we need to do, if we are going over this curve, we're going from 0 to 2, and we've got 4 equal intervals. Okay, so I need to find out what the interval is equal to, right? So maybe you can do it in your head. If you don't want to do it in your head, you're going to use that formula. Delta x is equal to b minus a over n. Okay, so a is 0, b is 2, n is that 4. So then I'm going to have a 2 minus 0 over a 4. That's going to reduce the lowest term, so each one's going to be a half. All right, most of you could probably have done that since the interval is just from 0 to 2. All right, I would highly recommend doing the little partial number line. I'm going to have 0 to 2 because that's my interval, and then put your little 3 hash marks in there so that you can see that this one is half, this one is 1, this would be 1.5. All right, and the only reason I highly recommend doing this is you can just see then, you know, if you're using a left, if you're using a right, if we're using the midpoints, okay? We'll figure that out here in a minute. All right, so what I would do for starters then, let me switch to yet another color here. All right, so I don't care which one we do first. Let's do a left first. Okay, now, even though it says a Riemann sum, all right, we do not have to necessarily use that summation notation, okay? Because now we're kind of past that initial introduction with using that summation notation. They've given me a function, intervals, all right, and we know these are going to be rectangles because it's a Riemann sum. So we're just going to kind of go with that that width times length, width times length, width times length. That's really the main thing that the IU professors want when they see this Riemann sum thing. Okay, so we can just say, what are we doing? We're approximating the area, so there's nothing wrong with saying the area equals. All right, now, I really don't care. The width is always going to be a 1/2, so I can do 1/2 times the height, 1/2 times the height, 1/2 times the height, or you can factor out the 1/2. All right, for right now, I know they're equal intervals, and it seems redundant to actually write 1/2 every time, but I would like, I think, you to be in that habit better than factoring that 1/2 out, because eventually these are not going to be the same width. Okay, so let's go ahead and do each one of them. So it's going to be the width, 1/2, times the height, which will be f of, we're plugging in the left, so 0. And then 1/2. Next rectangle, the left would be a 1/2, so times f of 1/2. Next rectangle is going to be the 1 to 1/2, so our left endpoint is going to be our 1, 1/2 f of 1. Last rectangle, 1/2 f of 1 and 1/2. So even though it's got the word Riemann sum in there, don't think that you have to do that summation notation. The idea of a Riemann sum in general is just length times width plus length times width plus length times width. Okay, and you've showed that. It says do not evaluate, so literally that's all you have to write down, because it doesn't say evaluate. And the thing that I would be looking for are these numbers right here. Did you use the left endpoints? Okay, now let's do a right. All right, so again, I might start out with the area is approximately equal to, okay? All right, so width is going to stay the same, 1/2. But on this first rectangle, my right endpoint is the 1/2, so f of 1/2. Second rectangle, 1/2. F of second rectangle will be a 1 on the right side. Third rectangle, my right endpoint is going to be that 1.5. Last rectangle, the right hand side is going to be the 2. 1/2 f of 2. Okay, 4 rectangles, 4 things I'm adding up. Okay, straightforward. Now, on the midpoint, okay, this one's the midpoint. Some of you are going to do it in your head. Others of you might want to add them to the diagram there. Halfway in between 0 and 1/2 is 1/4. Halfway in between 1/2 and 1, 3/4. Halfway in between 1 and 1/2, 1 and 1/4. Halfway in between 1/2 and 2, 1 and 3/4. And if you added them to the diagram like that, it might be a little bit easier than if you're trying to do it left to, like as you go left to right, you might be more apt to make a mistake. All right, it didn't take us very long to add them up there. Okay, so now I have to think first rectangle, but I'm not going to use the left number. I'm not going to use the right number. I'm going to use the midpoint. So it's going to be a still width of 1/2. I'm plugging in 1/4 into the function to get the height. Okay, second rectangle will still be the 1/2. All right, again, not the left, not the right. I want the middle, the midpoint, so f of 3/4. Third rectangle, I'm plugging in 1 1/4. And then last rectangle, we would be plugging in that 1 3/4. So 1/2 times f of 1 3/4. And then since we're not evaluating on this particular given question, they just, something like this is they're just trying to test, do you, one, understand what a Riemann sum is? Can you figure out what the intervals are? And then can you figure out what the left and the right and the midpoint is? So the midpoint's the new one. You should have been really good with the left and right. That was on our last quiz. All right, but the midpoint was new.